Welcome to our channel. Today, we're embarking on a cosmic journey to explore some of the most mind-blowing planetary phenomena in the universe. Get ready to have your mind blown wide open as we delve into the extraordinary, the unexpected, and the downright bizarre. We'll be venturing beyond our familiar Earth, journeying to distant star systems and encountering planets that defy our wildest imaginations. From planets that break free from their stellar tethers to those with hearts so hot they glow like stars, we'll uncover the secrets of these celestial wonders. Fasten your seatbelts, space explorers, because we're about to blast off into the fascinating realm of planetary science. Prepare to be amazed. Imagine a planet, adrift in the vast emptiness of space, untethered from the gravitational embrace of a star. It sounds like something out of science fiction, but these rogue planets, these cosmic exiles, are a reality. They're out there, wandering the interstellar void, and their stories are as captivating as they are mysterious. So, how does a planet become a rogue, cast out from its home star system? It's a tale of gravitational interactions, a cosmic dance where sometimes planets get flung out of the system. Picture a star system still in its infancy, a chaotic nursery where planets are forming, jostling for position around their stellar parent. These young planets, still finding their cosmic footing, exert gravitational influences on each other, tugging and pulling in a celestial game of tug-of-war. And sometimes these gravitational interactions can become so intense that a planet receives a cosmic kick, enough to send it hurtling out of its star system and into the interstellar abyss. Now imagine you're on this rogue planet. What would you experience? First, bid farewell to the warmth of a sun. The planet would be plunged into an eternal frigid night, the once familiar starlight fading to a distant glimmer. Temperatures would plummet to unimaginable lows, hundreds of degrees below freezing. Any atmosphere the planet once had would likely freeze solid, creating a desolate, icy landscape. But even in this frigid darkness, there's a glimmer of hope. Scientists believe that some rogue planets might still harbor internal heat, remnants of their formation or the result of radioactive decay within their cores. This internal heat could be enough to maintain a subsurface ocean of liquid water, shielded from the frigid temperatures at the surface. And where there's liquid water, there's a possibility, however slim, of life finding a way. These rogue planets, though seemingly desolate, offer a tantalizing glimpse into the potential diversity of planets in our universe. They challenge our assumptions about what a planet can be and where life might exist. So the next time you gaze up at the night sky, remember those cosmic wanderers, the rogue planets, silently traversing the interstellar sea. We're used to the image of volcanoes erupting with fiery molten rock, but the universe has a far more exotic spectacle in store for us. Ice volcanoes, spewing forth plumes of icy particles, a phenomenon known as cryovolcanism. Imagine this. You're on a spacecraft, approaching a moon covered in ice. As you get closer, you notice plumes of material erupting from the surface, reaching hundreds of kilometers into space. But instead of fiery lava, these plumes are composed of water, ammonia, methane, or other volatile substances, frozen solid in the extreme cold of space. This is cryovolcanism, a process driven not by the intense heat of a molten core, but by the tidal forces exerted by a nearby planet or moon. These tidal forces create friction within the icy moon, generating heat that melts subsurface ice, creating vast reservoirs of liquid water beneath the frozen surface. And then, with incredible force, this icy slush erupts through cracks and fissures in the surface, creating spectacular plumes that can be seen from space. One of the most stunning examples of cryovolcanism is found on Enceladus, a moon of Saturn. This tiny moon, barely wider than the state of Arizona, harbors a subsurface ocean that's more extensive than all the oceans on Earth combined. And through cracks in its icy shell, Enceladus erupts geysers of water vapor, reaching hundreds of kilometers above the surface. These geysers, analyzed by passing spacecraft, reveal tantalizing clues about the composition of Enceladus's subsurface ocean. They've even detected organic molecules, the building blocks of life, hinting at the possibility that this icy moon might be harboring life in its hidden depths. Cryovolcanism isn't just confined to Enceladus. It's been observed on other moons in our solar system, including Europa, Triton, and Ceres, each with its unique cryovolcanic activity, painting a picture of a solar system far more dynamic and diverse than we ever imagined. So the next time you think of volcanoes, remember that the universe has a far more imaginative repertoire than just molten rock. It's a universe where ice erupts in spectacular plumes, a universe where even the coldest, most distant worlds can harbor hidden oceans and the potential for life. Let's dive into a truly alien concept, a planet completely covered in water, a world without continents, islands, or any land whatsoever. Picture a planet that's one giant ocean, stretching from horizon to horizon, a world where the depths have never seen the light of a sun. These hypothetical worlds, known as ocean planets, are thought to form in the outer regions of star systems where icy material is abundant. As these planets coalesce, they accrete vast amounts of water ice, eventually becoming enveloped in global oceans hundreds, even thousands of kilometers deep. Now, imagine the conditions on such a planet. The surface would be a churning, turbulent expanse of water, whipped by storms and battered by waves of unimaginable size. But as you descend deeper, the pressure would increase dramatically, the weight of the water above crushing everything in its path. Eventually you'd reach a point where the water is so dense that it becomes a strange, exotic form of ice, known as Ice 7, which remains solid even at incredibly high temperatures. This layer of Ice 7 would act as a barrier, separating the liquid ocean above from the planet's rocky core below. But here's where things get really interesting. Scientists believe that hydrothermal vents, similar to those found on Earth's ocean floor, could exist on ocean planets as well. These vents, spewing forth heat and chemicals from the planet's core, could provide the energy for life to thrive, even in the absence of sunlight. Imagine creatures adapted to crushing pressure, navigating the ocean depths by bioluminescence, their forms and metabolisms unlike anything we've ever encountered. Ocean planets, with their potential for unique ecosystems, challenge our understanding of where life might arise and what forms it might take. They remind us that the universe is full of surprises, and our own planet, with its familiar land masses and shallow oceans, might be the exception, not the rule. So the next time you look out at the ocean, let your imagination drift to those hypothetical worlds, those water worlds where the depths hold secrets yet to be uncovered. Get ready to explore a truly mind-bending concept. A planet whose core is so hot that it glows like a star, illuminating the planet from within. Imagine a world where the night sky is aglow with the eerie internal light of the planet itself. This might sound like pure science fiction, but it's a theoretical possibility, a testament to the extreme conditions that can exist in our universe. So how could a planet's core get so hot that it glows? There are a few potential culprits. One possibility is intense radioactive decay happening deep within the planet's core. Certain radioactive isotopes, remnants from the Big Bang or supernova explosions, can generate heat as they decay. If a planet formed with an unusually high concentration of these isotopes, its core could remain molten, even billions of years after its formation. Another possibility is tidal heating, similar to what we discussed with cryovolcanism. But in this case, the gravitational forces are so intense that they generate enough heat to keep the planet's core in a molten or even plasma state. Now imagine you're on this planet with a glowing core. The surface would be a truly alien landscape, bathed in the eerie light emanating from below. The atmosphere, if one exists, would likely be turbulent and dynamic, driven by the intense heat radiating from the core. The very ground beneath your feet might be unstable, prone to volcanic eruptions or geysers of molten material. It's a world in constant flux, shaped by the immense energy emanating from its heart. But could life exist on such a hellish world? It's highly unlikely that life as we know it could survive on the surface of a planet with a glowing core. The temperatures would be extreme, the radiation levels potentially lethal. However, it's not impossible that life could find a way to exist in more shielded environments, perhaps deep underground or in pockets where conditions are more hospitable. The universe has a knack for surprising us, and life has a remarkable ability to adapt to even the most extreme environments. So while planets with glowing cores might seem like the stuff of science fiction, they serve as a reminder of the incredible diversity of worlds that might exist in our universe. They push the boundaries of our imagination and challenge us to consider the possibility of life thriving in even the most unexpected places. Thanks for watching. If you enjoyed this video, don't forget to like, subscribe, and hit the bell icon for more fascinating content about our universe. We've covered some truly mind-blowing planetary phenomena today, from rogue planets wandering the interstellar void to ocean worlds covered in unimaginable depths of water. Remember, our exploration of the cosmos is just beginning. There are countless more mysteries to uncover, countless more wonders to amaze us. So keep that sense of wonder alive, keep asking questions, and keep exploring the universe around us. Until next time, keep looking